So let's see the example here, right? So what does the const keyword do here, right? So it will uh, keep the value of x constant after initialization. So once you initialize x is equal to 10, and now if you try to do x is equal to 20 here, right, you will get an error. And if I have to show you, make, right, we are getting a compilation error, right, that uh, x is a constant and we are assigning some value to it, right? So this I hope is clear. So what does const do is it will not allow us to modify any variable after we have initialized it. It is a good way to tell compiler or the other programmers that this is not supposed to change, and it will remain constant throughout your code, right? So that's about the usefulness of what const is. And yeah, another thing is you will always get the errors at compile time. Now let's talk about what happens when pointers come into the picture, right? So when a pointers come into the picture, there are two entities now, right? So the point one is the pointer and the other is the object that it is pointing to, right? Now both of them can be variable, right? So pointer can also be a variable and your uh, object can also be a variable, right? So when we apply const keyword to this semantic, right, so we can make either of them constant or we can make both of them constant. And how do we do that? Let's see that, right? So let's comment this. So we have a const int x, right? So here your x is of type const int, right? So here if we see the error, right, it shows that the const qualified type is const int, right? So its type is const int, right? So what should be the pointers type, right? So here we define our pointer like this: const int star pointer, right? And if we try to uh, right, so we will get so now let's print it, and I think we will get the same result here. So let's make and let's do const, right? Yeah, the value pointed by the pointer is also 10, right? So what did we do is uh, we made a pointer which was pointing to a const int, right? So and we just printed the value out of it, right? So now here again, as I said, right, there are two entities. One is the pointer itself and one is the object it is pointing to. So here in this case, the object it is pointing to is constant. Pointer is equal to 20, right? This line will also cause a compilation error because now you're trying to change the value it is pointing to, and that is constant. But here um, can you change the pointer itself? So that can happen, right? So let's assume we have another const int y is equal to 15, right? Now what will happen in this case, right? So if we want pointer is equal to and y, right, this won't give an error because your pointer was not the one that was constant. So you could easily change the pointer. So this is right. Now if we want to make and add constant, right, so the value pointed by pointer now is going to be 15 because you change the pointer, not the object it is pointing to. So that's how it works, right? And yeah, so now there is another type how we can make the uh, pointer constant, right? So let's assume here we have something called right, so let's come down and we have uh, any variable which is not constant, right? So let's say int z is equal to 11, right? So now it so once we want a pointer to it, right, so we want a constant pointer that is pointing to int z. So how will we write this? The type will be int star, but this time we will write that a new pointer, right? So pointer 2, let's say, and it will be pointing to z, like the copilot is showing, right? So now here if you see, right, here the pointer is a constant and it is pointing to an object of type int star or int, right? So what does this mean is that you cannot change the pointer, you cannot point it to something else, but you can, it is not pointing to a constant thing, right? So now if you want to change something like star ptr2, oh, sorry, not here, yeah, let's okay, let's first do this. And now if you want to change it to let's say 20, right, this won't give an error and it will compile, right? So, and if we want to see, right, so it was 11 earlier and now it is 20, right? Because the int was not the constant, the pointer was the constant, right? Now but what happens when we try to change the pointer here, right? So okay, and right, so now let's say if we have int a is equal to 20 again, right? So because the pointer has been constant, so you cannot now change the pointer, right? So pointer to, if you try to do this, right, you will get a compilation error again. And if you want to see what is the error, right, because pointer 2 is a constant pointer, right? So it says that it is a constant pointer, right? At the above it was showing so type constant, but here it will show that it is constant pointer, right? Okay, so what, and there is a third variation, so let's comment this first, right? And this will cause a compilation error. And there is a third expression we can write, so, and that is of type, let's say if we have const uh, int a is equal to 25, right? So if we have something like const uh, in star, right, and const pointer 3 is equal to and a, right? So what does it means is that your pointer is also constant and your int is also constant, right? So if you change either your pointer or your object, both of them will give you a compilation error, right? So you cannot either change your the object it is pointing to, and you cannot change the object itself, right? So both of them will give an error. So what this means, so is that it is a constant pointer which is pointing to a constant object, right? So yeah, so usually there is a way we read this const keyword here, right? So because these expressions can be confusing, right? So now as we saw it, there are three types of uh, expression you can write while your pointers are concerned, or while your const keyword is and pointers are concerned, right? So these three are there, right? So, and this can be a bit confusing, but how do we read them is right to left, right? So ptr is a pointer which is pointing to int, that is constant, right? And if you want to read this expression, so we can say that a constant pointer ptr2 is pointing to a const int, right? And if we want to read this, we can read this in this way, that it is a constant pointer 3 which is pointing to a constant int, right? So it is always read from right to left. So you will see that if it will be like pointer which is pointing to const int, right? So yeah, it is always read from right to left. Now talking about this, right, so there is one more variation of how we can write const keyword. So the idea remains same, but the expression becomes a little bit different and a little bit more readable. Yeah, so this is called east const method, right? So to write the const keyword. So, and this is more readable and this is more recommended style. uh, in C++, right? Because because of its readability, right? So here in this style, what we do is, uh, here the one rule that sets his that the const will always lie to the right of the type that is being constant, right? So let's say here, uh, if I have to give you an example, right? So here int is the one that is being constant, or the object the pointer is pointing to is become constant, right? So the east style is that you will write const keyword right to it, right? And let's say east ptr, right? Okay, so this will also work, right? And it is called uh, east const style, right? And it is equivalent to this, uh, right? What we just saw, right? And yeah, here this is already equivalent to east const style, so it means, so if we again have to write, right, pointer, let's say east pointer, right? Because const is already lying to right to the pointer star, right? So this is how the eastern equivalent of int star const pointer looks like, right? And yeah, for third again it will looks very similar, just a const will lie to the right of what you're trying to const. So here, so if you want int to be constant, you will write const to the right of it, and then if you want pointer to also be constant, so then also you will write uh, pointer to the right of it, right? So as it says, right, so it becomes eastern equivalent of const in star const, right? So that's how we write our const keyword, and that's how we read const keyword and understand what is being constant, if it is the pointer being constant, or if it is the object that is constant, right? Or both of them, right? And here one thing I would like to share is, let's talk about what happens in case of reference, right? So reference, the rule of reference also remains similar, right? So wherever how we can write pointers, it we can also similarly write references in the same way, just there is one fundamental difference, right? That happens in this second case. So once we're trying to write here, if we see, right, so we made the pointer constant, and we pointed it to an variable object, right? But fundamentally, if we try to do this to reference, it won't make any sense, right? Because reference are always constant, so you're assigning a constant keyword to another constant, so that won't make any sense. So once you initialize the reference, as you might know, we cannot change it, right? So we cannot modify it, right? And yeah, so that won't make any sense, but uh, you can use the rules similar in a similar way, right? So yeah, that is all.